What if I told you that more than 2,000 years ago, without satellites, without telescopes, without modern instruments, a single man measured the size of the Earth using nothing but sunlight and geometry? What if the first person to calculate the circumference of our planet did it not from a mountain, not from a ship, but from inside a library? And what if this man was not just a mathematician, but a poet, a historian, a geographer, and the guardian of the greatest collection of knowledge the ancient world had ever seen? This is the story of Eratosthenes, the man who dared to ask a question so vast that it stretched beyond the horizon itself. How large is the world we live on? Stay until the end of this journey, and you will discover not only how he answered that question with astonishing accuracy, but also how his method still defines the way we understand our planet today. You will see how curiosity, logic, and a single shadow became powerful enough to measure the Earth itself. And you may begin to realize that one of the greatest scientific revolutions in history began not with an explosion of technology, but with a quiet observation under the sun. Eratosthenes was born around 276 BC in Cyrene, a Greek city in North Africa, in what is now modern Libya. He grew up in a world transformed by the conquests of Alexander the Great, a world where Greek language and ideas stretched from Egypt to India, creating a vast intellectual network unlike anything seen before. Knowledge traveled across continents. Scholars debated mathematics, astronomy, philosophy, and geography in an interconnected world that almost feels surprisingly modern. From an early age, Eratosthenes displayed a restless curiosity that refused to stay within one discipline. He studied in Athens, the intellectual heart of the Greek world, where philosophy, poetry, and science were not isolated subjects, but parts of a unified quest to understand reality. He learned mathematics, but he also wrote poetry. He studied astronomy, yet he was equally fascinated by history and literature. To later generations, this versatility would earn him a curious nickname, Beta, meaning second best, in many fields. Yet this label hides a deeper truth. Eratosthenes was not second best. He was something rarer, a universal mind, capable of seeing connections where others saw only separate branches of knowledge. His life changed forever when he was invited to Egypt, to the dazzling city of Alexandria, the intellectual capital of the Hellenistic world. There, under the patronage of the Ptolemaic kings, stood the legendary Library of Alexandria, not merely a building, but an ambitious attempt to collect all human knowledge in one place. Scrolls arrived from every corner of the Mediterranean. Histories, plays, mathematical treatises, astronomical observations, and travel accounts filled its halls. Eratosthenes was appointed its chief librarian. Imagine the scene, a man surrounded by the accumulated wisdom of the known world, reading reports from travelers, comparing geographical descriptions, analyzing astronomical notes, and searching for patterns that others had overlooked. The library was not just a storage space, it was a laboratory of ideas. And inside this laboratory, a simple piece of information would ignite one of the greatest scientific insights of antiquity. Eratosthenes learned that in the city of Syene, far to the south near the Tropic of Cancer, something remarkable happened each year at noon on the summer solstice. On that day, the sun stood directly overhead. Vertical objects cast no shadow. Even sunlight could reach the bottom of deep wells. The sun, for a brief moment, appeared perfectly aligned with the earth below. This detail fascinated him, because in Alexandria, at the very same time, on the very same day, vertical objects did cast a shadow. Why? That question contained a hidden revolution. If the earth were flat, sunlight would strike both cities at the same angle, and the shadows would behave identically. But they did not. The difference suggested that the earth's surface was curved, causing sunlight to meet each location at slightly different angles. Here, inside the quiet halls of a library, Eratosthenes began to imagine the earth not as a vague sphere suggested by philosophers, but as a measurable geometric object. He realized something extraordinary. If he could determine the angle of the shadow in Alexandria and know the distance between Alexandria and Syene, he could calculate the entire circumference of the Earth. The idea was breathtaking in its simplicity. Measure a shadow, measure a distance, measure the world. On the summer solstice, he placed a vertical stick in the ground in Alexandria and measured the angle of its shadow. The angle turned out to be about 7.2 degrees, roughly 1/50th of a full circle. This meant that the distance between Alexandria and Sienne represented 1/50th of the Earth's total circumference. Now he needed the distance between the two cities. Ancient surveyors, likely using pacing or caravan travel estimates, had measured this distance at approximately 5,000 stadia. Multiplying that number by 50, Eratosthenes calculated the Earth's circumference at about 250,000 stadia. Depending on the exact length of the stadion used, modern scholars estimate that his result was astonishingly close to the true value, within a few percent of the Earth's actual circumference of about 40,000 kilometers. Let that sink in. With no satellites, no airplanes, no modern instruments, Eratosthenes measured the size of the entire planet using geometry, sunlight, and careful reasoning. His achievement was not merely a calculation. It was a demonstration that the Earth was a knowable object, governed by mathematical principles that human intelligence could uncover. But his curiosity did not stop there. As librarian of Alexandria, Eratosthenes began to systematize geographical knowledge. He created one of the earliest maps of the known world, introducing a grid system of latitude and longitude to describe locations more precisely. In doing so, he helped transform geography from a collection of travel stories into a structured scientific discipline. He even attempted to calculate the tilt of the Earth's axis and contributed to early chronologies of world history, trying to place historical events within a consistent timeline. His work reveals a mind driven not by isolated discoveries, but by a unified vision. The world is intelligible, measurable, and interconnected. Yet, like many great thinkers of antiquity, his legacy would face a long and complex journey through time. Later scholars would preserve fragments of his work, while others would misinterpret or challenge his conclusions. Some medieval traditions would forget the precision of his measurements, while others would rediscover them centuries later, astonished by their accuracy. His method, however, never truly disappeared. It remained embedded in the scientific imagination, waiting to be reborn whenever humanity again asked, "How large is our world?" Perhaps the most intriguing aspect of Eratosthenes' story is not just that he measured the Earth, but how he did it. He trusted observation, he trusted geometry, and above all, he trusted that the universe operates according to consistent rules that can be uncovered through careful reasoning. This intellectual confidence became a cornerstone of scientific thought. It suggested that nature is not random chaos, but an ordered system accessible to the human mind. In a sense, Eratosthenes did more than measure the Earth. He measured the power of human curiosity. He showed that even without advanced technology, disciplined thinking could reveal truths on a planetary scale. His experiment transformed the Earth from an abstract philosophical concept into a concrete, measurable reality. It shifted humanity's perspective from living on an immeasurable plane to inhabiting a finite, comprehensible globe suspended in space. And this shift carried profound implications. If the Earth had a size, it also had limits. If it had limits, it could be mapped. If it could be mapped, it could be explored. Centuries later, explorers, cartographers, and scientists would operate within a conceptual world that Eratosthenes had helped define. Standing in the library of Alexandria, surrounded by scrolls and silent sunlight, he had quietly redrawn the boundaries of human knowledge. So the next time you see a shadow cast by the sun, remember that once, long ago, a thinker looked at such a shadow and saw not just darkness on the ground, but the curvature of the entire planet. From a single observation, he imagined the Earth. From a simple angle, he calculated its size. And from within the stillness of a library, he expanded the horizon of humanity itself. This is the enduring legacy of Eratosthenes, the man who proved that even the vastness of the world could be measured. If only we dared to ask the right question and trusted reason enough to follow where it led.